Hi there all today. I've given the carbon chip a resurfacing. I'll just plug in the light. Didn't quite turn out how I wanted it to. It was had a layer of copper completely over it. I pulled one of the cells apart. That was the copper. That's 1 foot of wire. It's still pretty intact for the amount of copper what was in the tub. That was from the very first cell, the plain carbon and copper electrode. So this was coated in copper, and I thought I'd plate over the top of the copper, and I had the zinc plate connected to the positive. It sucked all of the copper from that carbon and layered it on top of the zinc cell. But the zinc also came apart, and in fact it coated the cell anyway. But I did want the copper under it, but it doesn't matter. And today we're just going to go for a slightly different one. All manganese dioxide in a carbon rod, wrapped in some paper towel with the cellulose acetate membrane coated on the towel. The weather's way too hot to coat this. I've failed every attempt trying to make the same plastic sheet made during the winter. They're not releasing from the metal they're coated on, even soaking in water, and yeah, turning out to be a nightmare that. So, and the electrolyte today is potassium hydroxide. It's a very weak solution. It really didn't do much in my nickel iron cell, so I'm not sure how well that's going to go. But I did coat this in the same solution of potassium hydroxide this time. So yeah, alright, we'll put that in there and let it soak up. Turn on the meters. Okay, that's the carbon zinc cell in, and manganese and paper towel in cellulose acetate. There's 1 gram again on that, coated around, probably around about there. So I'm not sure what it's going to be like, but I think the copper was deplating itself and interfering with the current electrode setup. So we're at 0.9, strange for potassium hydroxide, and a short circuit. We've got 11 milliamps. Won't even be enough to run that motor. Oh, no, not quite. Yeah, I'll just put the glasses on and top up the electrolyte. Glasses with this stuff. You can't afford this stuff in your eyes, even at this weak concentration. As you can tell, I just spilt some. Really bad with my electrolytes. That's why I haven't moved on. Oh, that's still on a short circuit. Alright, so got the charge set on about 3 and a bit volts. I'll give it a charge for a couple of minutes, or a second, 10 seconds. Okay, that's about 20 seconds of charge. We'll do a short circuit just for a check. Only got 40 milliamps. We do run the motor. Alright, I'll leave it at that and give it a charge for an hour, and I'll get back. Hi there. It's been 1 hour's charging on around about 3 volts. And we've been running for 1:22. We're holding 1.3 volts. The load is 30 milliamps and the cutoff is 0.49 volts. Yeah. At first it didn't look like it was going to be any good, so I wasn't going to put it on. But it surprising. Well, I only had the voltage and stuff I was looking at to prove that it wasn't very good. Sometimes my guesses aren't very good. But yeah, maybe. The voltage is a lot higher, but we'll see how long that actually lasts for. The cell was pretty constructed crudely. I just paper towel and some 1 gram of manganese dioxide and wrapped it around a carbon electrode. It sort of wasn't as good as that material, but the separator on the paper towel may be having something to do with holding the voltage a bit better. Because standard paper towel and everything, probably not the electron size pores. Just a guess. But yeah, I think, and also the well, this test might prove it, but the copper was a hindrance. It did actually function as nothing. In fact, you get a higher voltage with just plain carbon than this and zinc cell. Alright, we're at 2 minutes. This will be the negative, the carbon, carbon and zinc cells, about 45 charges. So the carbon zinc cell's holding up, but the second plating of it, because it got coated in copper, which was hindering the process, I reckon. So hoping the second charge is going to be like this as well. So far I'm impressed with the voltage, but I've had it up for about 10 minutes at 1 volt on some of the other cells, so it's hard to say. Alright, I'll let this thing continue and I'll get back and see what we get for energy density and stuff. Okay, it ran for 11 minutes. It delivered 6 milliwatt hours after an hour's charge. And I'll save this out. Okay, I saved that out. I'll just see if it's got any power left. Somewhat drops quite quickly. So recovery is a little bit not too bad. Alright, I'll try a 2-hour charge and we'll compare the run time. Till then, I was thinking about that positive electrode construction. I'm not too happy with that one, so I might get that chip, weigh it up. It's quite dry, it's been out of solution for a while. Oh. Alright, we're on 0. Okay, we weigh 9.1 gram. Okay, so what I'm going to do with this is I'm going to mix up some manganese dioxide and submerge that into it and push it through it as much as I can, and then I'm going to make another separator with some cellulose acetate on it and wrap that up and use that as the cell. But that will be after this 2-hour test. I think it's too loosely bonded in there, as our run time was quite down. The voltage is high but lacking power density. Okay, back almost 2 hours. The meters are showing 47.6 milliamps and 3.44 charge voltage. The cell's still pretty clean. You can see by the liquid on the side there. And maybe down here. No, not so well. Okay, time we set up the machine. Should be good. Okay. Alright, that's all set up. 30 milliamps. Cut-off voltage 0.49. Disconnecting the voltage. We should get droppage. Yep, so it's working still. Multimeter's showing 2.28 volts and holding, and that's showing 2.3 and dropping. Alright, turn these meters off and we'll start the test. Bit of luck, we get 10 minutes at 1 volt. After all, it did have a 2-hour charge. Could be acting like a capacitor. It seems to just start dropping. There's no holding. We seem to be somewhat up here. It's normally around 0.03 or 2. Alright, I'll let that run its course and I'll be back. Okay, we got a whopping 6 minutes more, I think, on an extra hour's charge. We got 16 minutes and we're only 8 milliwatt hours. So we were 6 milliwatt hours on a 1 hour charge. The voltage is quite high. That's one good thing about the cell, but that's about it. But there's not a lot of material on the active electrode there. So let's see if it's got any more power. The other one I think dropped down to 0.5 volts. Oh yeah, look, 0.7. But dropping rapidly, so there's not too much going on in that cell, but like I said, there's not much material. And the paper towel somewhat wraps itself around each other, so that's an extra layer of insulation, which might not be helping the cell. And for the cell itself, let's pull it out of the electrolyte. On the meter, 21.8 volts. Right, we'll do a short circuit. Okay, right, short circuiting. 44 milliamps. Holding, sort of. And no copper, sort of, only what was in that area, what didn't get laced. Or is it there? I could have coated it. I can see bits of copper under there now. And the positive electrode is only bundled up like that. Could be leaking out the bottom. I just folded it around and wrapped the rubber band around it. Could all be coming out the top as well. Ah, there's a patch of it. I can feel it. It goes somewhat tight. And does it run the motor? Yeah, runs the motor. Does 28. 0.7 after running it down. Somewhat impressed with it. I'm going to work on this positive electrode, get this one covered, and then I'll try to wrap it with the bare minimum overlap and see how this goes. It's probably going to have a much better surface area than that rod with a bit of coating. Alright, I'll get back, I'll do that tomorrow. Hi there, that's 14 hours after a charge. The voltage is 1.7, which is looking good. Looks even better on the data logger. It's 1.77. I've got the parameters set. Oops. Change that to 30 milliamps actually. And cutoff voltage 0.49. And we'll give it a run, see how long it lasts. I don't presume it's going to last long at all actually. So let's have a look. Hey, straight off. No power in that cell, so it's all voltage and nothing else. We'll back off to 30 milliamps. We'll put 20. We'll see if that does anything. So the voltage is good, but the power density is very poor. All I have to do is try to mix them. Nah, look at that. That's a shameful cell. We'll do a cutoff voltage of less. So this cell's all voltage and that's it. Alright, it's doing 20 milliamps. So let that do its thing. So the cell's okay-ish, but zinc one looks alright. I think it's the positive electrode which is the problem here. I don't think it's formed quite right. So today I'm going to coat that one manganese dioxide. Try to embed it into there as deep as I can. This was 9.1 grams. And then we'll measure it after it's got the separator and the manganese dioxide embedded into it, and we'll test this one out. That one's a bit of a flop. The voltage is good, but the rest of it is poor. Alright, I'll be back when I set that other cell up. Here we're checking the cell's response for a higher charge. We've been charging for 49 minutes and the voltage is 5.6, so I'll disconnect the charger and the voltage is probably stabilise at 2 milli, but we'll see if we got any power in the cell. We're on 30 milliamps and cutoff voltage is 0.49. Not as good as it was, I don't think. It was holding 1 volt before for over 5 minutes. Well, that satisfies my curiosity there, so I'm going to now construct the cell and give this one a test. I don't think this has got much in it. I reckon the active material may have spread itself out along the electrode on this one. It was crudely made, that cell, so yeah. Alright, I'll make the new cell and we'll try that out. weighing the new Electrode's paper towel membrane. .71 grams. Weighing up the final Electrode in weight. .26. Right, again, so it's got apparently 13.55 grams of manganese dioxide coated around the carbon cell, but that's the wet weight of the manganese dioxide. I had to put it in distilled water to make a paste and push it through. So putting it in the cell, if it fits, hopefully. It's a bit tight. Yeah, nice and squishy, but it goes in like that. Providing we got good connection. I'll connect the lead. We got 1.45 volts. Do a short circuit. If I can find the lead. Here it is. Okay, short circuiting. 28 milliamps. It's enough to run that motor. And no charge or anything as yet. It's in potassium hydroxide, but a somewhat weak solution. And we'll see if it does anything on the data logger. I got 30 milliamps set and cutoff voltage 0.49. Well, at least it's running better than the last cell. Somewhat working okay. So I'll give it a, we'll disconnect this first. The voltage isn't going down so quickly, but it is. Yeah. Alright, so we'll disconnect that. I'll give it an hour's charge at 2.5 volts, I think. I'll turn that down now. Alright, about 2.5 volts for an hour and I'll get back. Okay, we've done a half hour's charge. And voltage is 2.79 there, and on the meter 2.77 and 37.7 milliamps. Okay, so we'll disconnect the charge. Okay, we're holding 1.9 on the multimeter and 1.983 there. Alright, let's see after a half hour if the cell's got any energy. Okay, we're at 30 milliamps and 0.49 cutoff volts. And starting now. Alright, it's looking okay. 1.2. So it is somewhat higher than it originally started at, so that's a good sign. The contacts on the carbon electrodes may not be so great. A couple of alligator clips. I might try a flat version of it with a copper pad behind one of the electrodes. That will definitely increase its surface contact. So we've got 2 carbon electrodes, one with zinc coated on it and the other one with a paste of manganese dioxide and probably whatever carbon they used. And the electrolyte is potassium hydroxide, a pH upper. Is it upper or down? Upper. Alright, I'll let this do its thing and I'll be back when it's done. Hopefully we get more than 10 minutes. Well, it was 9 minutes. 8, yeah, probably 8. And only 4 milliwatt hours. That's pretty much down on the other one. Pretty sure it's got a lot to do with the how we're connected to the carbon. I might try a stainless steel plate down the side there if I can fit a piece, or if actually I can find a piece. I've got some real thick stuff here, well 1.6, but I don't know. Somewhat disappointing, but the concept sort of works, I guess. Alright, I'll leave you with a bright screen and I'll see if I can improve the connection of those alligator clips somehow. Just as I turned away, I remember I have stainless gauze. I can jam that in between there and we can connect to that. We'll see if that improves it. Alright, have the stainless gauze connecting. We're down on voltage, and for a short circuit we're really down there. Wonder if I can wedge it. Right, we'll crank up the charger to 5 volts, see what happens when we'll do a little charge. Charging at 5. Okay, that's about 20 seconds, we're up. But we're at 4.46 volts. And we'll do a short circuit. Short circuiting now. A little bit higher there. Alright, I'll try 15 minutes at 4.46 volts as a charge. Alright, I'll be back. Okay, we're still really high on the milliamps for some reason, and we're coming up to 14 minutes. Okay, disconnecting power supply. Right, what are we going to go to? We're dropping way faster with that stainless grid in it. And a short circuit, 75, 72. That was 15 minutes worth of charge at high voltage. It's up near the 5. Okay, looks like we're stabilised. Oh no, oh yeah, it went up. No, it didn't. It's going down still. Alright. We'll see if it works. What did we get before? We got 9 minutes on a half-hour charge, but it was only 2 volts. It's only mainly a concept video of making those carbon electrodes. I'm going to try, I got my graphite plates. So I'm going to try a zinc one. It's just a piece of zinc, one of that, and some manganese dioxide on the graphite plate. And then we'll put the carbon chips on the plates and substitute them and see what we get. I think I'll use the piece of copper on the back of the carbon. That'll be the next test. Alright, I'll let this run and get back. Alright, not going to wait for this too much longer. It's 3 minutes and we're at 0.6. I'm going to remove the negative electrode, the zinc carbon, and replace it with a zinc plate and repeat the experiment. Alright, the negative electrode is now the zinc plate. It's got 1.2 volts. And for a short circuit, 55 jump, oh yeah, hang on. Wait up, I'll clamp it properly. Alright, 61 milliamps, that's much better. I'm holding actually, yeah. Alright, let's see what the data logger has to say about that one. Definitely much more power. So the zinc carbon electrode may be touch broken by the looks of that result. Okay, right, we'll try starting the test. That curve looks a bit better. Still, only had 60 milliamps for a lot of manganese dioxide in there. Alright, just a test. I'll bypass the mesh and connect the power clip to the carbon rod. Yeah, it's still the same voltage actually. So we're connected just to the carbon with the alligator clip. And for a short circuit, 77, that's probably somewhat up. So the mesh is actually hindering the process, or it's overriding it, it's not bonded. Needs to be tightly pressed against it perhaps. It's alright, we'll give it a 15-minute charge again. Oh, we're off to scale there. Probably only 300, yeah, 350, oh, 340, sorry. Milliamps. Alright, I'll be back in 15 minutes and we'll see what results we get. Okay, slightly over on that one. That's the zinc electrode. Disconnecting the charge. 1.7 again. Oh, for a short circuit. 100 milliamps. Hang on, we'll put that back on the milliamp range. Well, that went down a bit. Alright, we'll try that out on the data logger. That was 15 minutes. The other one got about 1 minute, I think. Nearly. Not quite a minute, and it was dropping. Okay, so we're currently at 1.5 volts, doing a test. Plain zinc plate doesn't seem to be much of any difference anyway, except for it's getting consumed. I can see the edges are already jagged. I think they are. I'll have to pull that out of the potassium hydroxide to have a look though. Now it is a bit higher. When we get to 46, we're at 0.8 something on the last electrode. They're definitely not holding any voltage, so it's just constantly dropping. So I think more like a capacitor. Alright, I'll leave that and I'll be back for it. Okay, the zinc plate plain electrode negative has lasted 16 minutes and it's still at 0.5 volts. So now I'm going to try a flat cell. What I have for the active material is the manganese dioxide mixed in the Epsom salts and zinc sulfate solution, and we're going to apply that to, we're going to have 2 layers. We're going to apply the I'll show you over here. Okay, right, we have a zinc plate, a membrane, paper towel coated in cellulose acetate. I'm going to put some of the active material after I stop this test. Right. Give it a stir first. This is just to check the carbon compared to a bought piece of carbon in the same setup. Okay, so there's about that much on there. Get our second layer. Okay, that's 2 layers of active material separated between that. We've got our graphite plate. I might put the wrinkly side into the electrolyte. Okay, and a piece of copper for the collector on the outside. I've got it assembled on a piece of glass. Okay, fingers crossed. Right, 1.4, about average for that cell. And short circuit. That's alright, 90 milliamps. That's much improved. Bigger surface area, better materials there. We'll try it on the data logger. Okay, right. Yep, we're all set to go. Testing now. Well, that beats the other cells pretty much. Just in this little test, we'll give it a charge for 15 minutes and see what happens. And I might wrap it up in Glad Wrap and see if it lasts overnight. Okay, so that looks alright. We'll disconnect the test. Stop. We'll give it a charge up for what are we on? We're on 5 volts, so we'll charge it for 10 seconds. Alright, about 10 seconds. And we'll see what happens. Stabilizing at 1.6. Still going down. Mosquitoes flying around. Great. I'll let that run and then we'll charge it up for 15 minutes and see if we get a comparison. Alright, we just went. It's only got 4 minutes worth at 2 milliwatt hours. Alright, so I'll charge it up. Saying it's 3. I'll put it on 10 milliamp range. It's taking in 700 milliamps. It's down to 600. Yeah, I'll see if I can get back in 15 minutes. Okay, we're at our 15. Developed a bit of a smell charging that cell. It's 5.3 volts charge. It went down to 130 milliamps. Disconnecting the charge. Oh, we're at 2.4. Alright, let's give it a run, see what it drops down to. Oh, somewhat not too bad. It's a much bigger cell and it's got proper graphite plate. Well, I'm actually glad that one sort of worked. Still dropping there. It's Epsom salts 50% and zinc sulfate 50% mixed into the manganese dioxide. So definitely the material you use to make your cell has a major influence on it. I'd have to say this would be the best cell I've made so far. Especially this last week, my cells have been like terrible. Yeah. Alright, I'll let that thing go and we'll get back. There's a mozzie outbreak in here. That's right, I forgot the fly spray. Oh, hi there. It ran for 12 minutes. Bounced back to 1.3 and delivered 7 milliwatts. So I'm still not that impressed. The high end was alright. 4 minutes at, oh hang on, where's 1 volt? Around about 7 minutes on 1 volt. 6.5 minutes. And we'll see if it's got any power left. Huh? So not too bad, I guess. I don't know. I'll put the voltage down to about 2.5 and charge it up for an hour, and then I'll also wrap it up in some Glad wrap, keep the moisture in. Alright, so that ends that bit. I'll get back with that 1 hour's charge and we'll see what it goes at. Hi there, somewhat slightly over the 1 hour, but in the ballpark. We're at 2.3 volts. I'll disconnect the charger. Disconnecting. That was just over 2 the needle was for a charge. That was for 1 hour. So here we go. Wow. It's actually holding a little bit above the 2 volts. That's a record. But none of that's my material. Moral of the story is the bought product's pretty good. Yeah. I wrapped the cell up in Glad wrap. There she be. And we're at 1.9. So the layering technique must work pretty well between membranes. I did have a peak test with a piece of aluminium and a plate and the membrane earlier. I might have put it on this video, and that seemed to be okay, but it was only the 25 by 30 cell. So the this is the what is it? The main Epsom salts and oh, it's too late in the afternoon. And zinc sulfate electrolyte mixed into the manganese dioxide as the active material. Alright, I'll do a time lapse. Seems to be pretty good. Well, we got nearly 20 minutes out of it and 13 milliwatt hours. Somewhat down but higher on the voltage than the first few cells and stuff. See if it's got any power left. One last test. Yeah, not too bad. I'll give it another charge and I'll post this video. The other one can go on something else if it looks good the next day. Alright, thanks for watching.